many of you use Chat GPT or Perplexity? I mean, everyone, right? So perfect audience. So I'll be talking about MCP. Essentially, MCP is nothing but a protocol which helps in communication with AI agents or your AI assistant with external data source. Alright, so initially I'll talk about me. I've graduated from IIIT last year, working as cloud engineer at Searce. I work primarily in AWS, DevOps, and not limited to that. Also, I work across creating applications and monitoring, observability. Apart from that, I am a huge Barcelona fan. I watch football. Alright, so I'll talk about the agenda today. So I'll be covering about what MCP is, why do we need MCP in first place. We have powerful LLMs, right? So why do we need MCP in the first place? So I'll talk about that. I'll talk about the history of MCP, and I'll talk about how can we leverage MCP to orchestrate our AI workflow or creating an AI agent workflow, which Sai talked about in the last presentation. Then I'll come to a demo. Then we can wrap it up. All right. So first off, why do we need MCP? So we have LLMs, right? We have powerful LLMs. So for a data, we have GPT-4, which is trained on 1 petabytes of data, which is nothing but 1 million gigabytes. It has 1.8 billion parameters. So parameters is something which enables your large language model to create the context, create the tokens, or answer your prompt using the data it is trained upon. So why do we need MCP? So first off, this is something which is called a static knowledge cutoff. So when we talk about an LLM is nothing but a large language model. So large language model essentially is nothing but a neural network. Neural network, when we talk about a neural network, let's say for example GPT, it stands for generative pre-trained transformer. So by the name itself, it's clear. It's pre-trained on some data. So at a point, it's pre-trained on some previous data. The data keeps on growing, and we don't have context to the current data set. So that's where the static knowledge cutoff comes in. I'll give an example, very interesting example upon this. So as of 2019, when you query the GPT about what planet has the largest number of moons, the most number of moons, it will give you Jupiter 95. But after that, NASA just found out that Saturn has 146 moons. It surpassed Jupiter. But since it was pre-trained on a previous data set, it answered Jupiter and not Saturn. So this is something which is an example I would put for the static knowledge cutoff. Then we have something which is called as context window constraint. So context window is nothing but your ability of your LLM to process the data in a certain time amount, given the limitation of your tokens you're inputting, given the limitation of your output you are having, token output. So there is a paradox associated with this, which is nothing but when you have a large context window, the LLM will introduce noise into that. And when you have a very small context window, that will also not cover your prompt very accurately, which will answer your answer to your prompt based on the short window it has. So it won't give you the accurate response it needs. We also have tool integration complexity. Now, like I talked about the static knowledge cutoff for LLM. So LLM needs a data source, external data source integration with itself. So that's where we integrate some tools, maybe an agent, maybe a tool, which we had in our first presentation. So tools is a very important concept which is used in LLMs. So using the tools, you can call an external APIs, you can call an external functions. So that's where you integrate the tools with your LLM. And when you are integrating these tools with your LLM, let's say I have two LLMs with me which I use in daily life, one being the Anthropic, the other being GPT, and I have 10 data source. So I need 20 integrations. So I need to write the code for GPT with all the other 10. I need to have the integration with the Claude with the other 10. So I need 20 integration level two-level integration with the LLM. Then there is something which is called LLM hallucination. LLM hallucination is nothing but due to your data set being not accurate enough with your prompt, it will generate a response which seems it's correct, but it may deviate from the response which actually is correct. So it's like fabrication on that layer. So now coming back to the LLM hallucination, we usually see 3 to 16% LLM hallucination in any standard LLMs or GPTs, which is again a not very good thing to have in your day-to-day life. So that's where we introduce MCP to overcome these problems. So I'll talk about what MCP actually is. So MCP is a open standard protocol which bridges this problem. So instead of having the individual tools with your LLM, you can just have MCP client and you can have MCP server to connect to your data source. So that's the important feature of an MCP. So MCP is nothing but it bridges the gap between your LLM and the data source which you need to connect to. Now there are 4 features of the MCP which I'll talk about. See, first one being the universal standard. So like I told, it has the ability to connect your LLM to an external data source. This is done using something which is called as JSON RCP protocol. So this is a very crucial protocol. This was introduced by LSP. So you must have used IDEs for your development, right? So when you had IDEs back then, around 2018, 2017, so Microsoft introduced these language protocols, LCP, language context protocol, which helps in auto completion of your language regardless of what language you are using. It helps in debugging. It helps in also auto completing the text. So that's where the MCP was inspired to. The intention of the creation of the MCP was the brainchild of LCP. So this is something which helps in universally standardizing your data source with the LLM. Now it's a bidirectional communication. So you can also prompt the LLM using MCP and get the data back. You can also response the MCP, prompt the MCP to execute your functions, execute your task. It will do that. So it's a bidirectional communication. It's also stateful. So stateful is important because we need context when we are talking about LLM. So let's say I'm doing some X work and I deviate from that X work to do some Y work. So this X will be, I'm talking about EKS. In the second frame, I'm talking about Prometheus Grafana. So this context should be maintained to have enough accuracy for the LLM to generate the result. So yeah, you must have a concern about why security is the main problem with the LLMs and AI agents. So MCP bridges that gap as well. When you have MCP in place, you can just put a limitation to your LLMs to access what kind of data you want. You can have access across what action it can perform. It can only have read access, it can only have write access, or it cannot have access at all. I mean, it can only have access to limited data sources. And in the data source also, you can have limitations across, this is my schema, you can only access this schema. You cannot access the other schema. So that is also one thing which is very important, which bridges the gap. You also have when you query the AI assistant or an AI agent, you have an UI-based approval mechanism by the MCP client. I'll talk about MCP client in next slides. So you have the UI-based auto approval. So that's where you can also take a look at what prompt it is putting to access your data source. You can, based on the prompt, based on the response you see, you can just approve it or you can just deny it. So MCP is also assumed to be, talked about to be USB-C port for the AI applications, which helps in bridging the gap. Alright, so history of MCP. Like I said, MCP was inspired by the language server protocol. It was released by Anthropic in November 2024. It primarily had support for Python and Node.js SDK during that phase. It supports almost all the languages now. You can build your MCP server or MCP client using Java, Golang or whatever. So you have good support as of now. And in the December 2024, we had a wave of community servers which were published across. It had GitHub, Google Drive, Slack, Postgres, SQL, etc. integration for the MCP servers. So it enabled your AI assistant to talk with your data source. And the major breakthrough came by the industry when OpenAI, the competitor of Anthropic, adopted the MCP in their agent SDK. This enabled MCP to grow across all the verticals, be it your LLM, be it your LLM assistant, AI assistant, or be it your AI agent connection, or be it your agent AI workflow, agentic AI workflow. So, and in the March 2025, that's where again a major breakthrough came for MCP. That's where they integrated the OAuth, the authentication mechanism, which I talked about in the previous slide. And when you have the MCP server in place, I'll talk about MCP server in detail, but this streamable HTTP protocol is something which enabled your MCP server to be accessed remotely and not from your local machine. And we also had tool annotations, so we had a more security driven approach in the March 2025. They added tool annotations, so this allowed your MCP to have the access across what schema I need, what action I can perform. Then we had the first developer summit in San Francisco in the May 2025. This is the history of MCP, how it grew and what phase it currently stands in. It's been used across a lot of frames, a lot of companies I see. And this is also a very important protocol which helps in driving the agentic AI workflow. Yeah, so I was talking about MCP client and MCP server a lot. So I'll cover in brief what MCP client, what MCP server is. So as you can see, we have MCP host, which is nothing but your IDE or AI assistant or maybe your agentic AI. Inside that we have MCP client. MCP client is nothing but a protocol. It helps in bridging the gap between your MCP server and MCP host. That's your LLM. It has two functionalities, which is sampling and route, which I'll cover in the next slide. Then we have MCP server. Most of the server which we use in the industry, 90 to 95% of them are the STDIO based mechanism. So we have two mechanisms to communicate with the MCP server. The first one being standard input output, STDIO, and the second one being the streamable HTTP, which we saw was released recently by Anthropic. The functionality which MCP server provides is tools, resources, and prompts, which I'll cover in the next slides. So MCP server is nothing but a process which runs in your machine. It can be a Python-based process, it can be a Golang-based process, whatever the SDK you have for the MCP server, you can just integrate very easily. I'll show it in the demo, it's very easy to use thing. Alright, so MCP tools is nothing but you have your function call, you have your API call. This helps in enabling the MCP server to access your data source and perform actions on that data source using the MCP tools, using the MCP server tools. Then we have something which is called as resources. So resources is nothing but your data. It is just read-only access. You can have files, you can have PDFs, you can have JSON, you can have images, videos, whatsoever. So this resources helps in providing the resources to your LLM. So it has a large context and it can query, it can return the result even concisely and based on your requirement, what you prompted. And prompt is a very important thing. This was also released very recently. Prompt is a template which could be hard-coded in your MCP server. So this enables you to have your agentic AI workflow. This enables you to have your systematic agentic querying. So this is a very important thing which was released recently by the Anthropic. Then we will talk about the client functionalities. The first one being sampling. So sampling is nothing but your MCP server wants auto completion or maybe wants some context, maybe wants some plan what could it perform from your LLM. So that's where sampling on the client helps to communicate between these two. It bridges the gap between your LLM and MCP server. And root is something which defines the boundary, what access I can have to my MCP, what access I can restrict, what actions I can perform. So this is about the architecture. So yeah, I'll talk about MCP flow now. Let's say I'm prompting my MCP to show me the EKS cluster I have in my local machine. So this is the flow. I just prompt the AI assistant, which could be your GitHub Copilot or Amazon Q or whatever, and then the request goes to the MCP client. It does the intent analysis, what the intention of the user is. It transforms the request into a JSON RPC. This is the protocol which is used between communication of your MCP client and MCP server. And then MCP server is first initialized, then the protocol is requested, then MCP server does the action based on what your intent is. It connects with the data source, it performs the action using the tools, resources. It also returns the response to your server, to your client, then the client puts back the response to your LLM, and then LLM using the natural language processing, it returns response in a user-friendly format. Alright, so I have a demo. I'll be managing my EKS workload with MCP. So this is a demo application which I have built. So this is just very straightforward. It's using the config map, using the Nginx server. Sorry. Visible? Yeah, I need this. Visible, right? Okay. So it's very straightforward setup. I have my config map. I'm putting CNCF, some HTML into it. Then I'm making a deployment, calling that config map in my volume, attaching that volume to my deployments. Pretty straightforward setup. So I'll use the Amazon Q AI assistant to do this. First off, I'll just connect my MCP server to the Amazon Q. So we have a built-in feature, which we have a built-in MCP server, which enables you to, which enables my Amazon Q to talk with my local machine, maybe do some file search, maybe execute patch commands, list directories. So we can restrict the scope. We can have a global scope. We can restrict the scope to this particular workspace, only this particular VS Code window. I'll just name the MCP server. Then like I talked about the transport mechanism, we have two transport mechanisms. One is the STDIO and one is the streamable HTTP. Streamable HTTP is something when you have a remote execution to a remote MCP server. Then I'll be using UVX, which is again a Python package manager, which is, I've used this because it's faster than the traditional pip. Then I'll add some arguments to run this particular UVX installer, UVX package manager to run the MCP server. I'll give write access to my MCP server. So we can have the access restricted here. We can only have the read-only access. We can also define access to your schemas and whatsoever. Then I'll add the environment variables. Then I'll add the timeout so that if a request fails after 60 seconds, it will return me that the request has failed, maybe some internal error due to communication between your client or server. Okay, I missed this. Okay, so these are nothing but the tools which I talked about, the function calls which you can access. You can have your Amazon Q or whatever ID to access across. So this is the permission restriction you have. It will ask you every time you want, whenever the MCP is called, it will ask you every time to run the command. You can also allow it every time when you have the restriction across initial configuration setup. So in this you have access across manage EKS stacks. It will do managing the EKS stack. It will list me the Kubernetes resource from my AWS EKS account. It will get me the pod info, pod logs. It will get me the Kubernetes events. Yeah, so we have 14 of these. I'll show the demo video because I don't have a lot of time. So I'm deploying an error-based YAML file which has this particular error. So the config map is not being referred correctly in my deployment. This is there I'm putting intentionally. I've applied the file. It creates the resources and the pod goes in container creating errors state. Now I prompt my MCP. Now I prompt my Amazon queue, which is nothing but my IDE or LLM, to fix the error, debug it. Yeah, I've put the context of this current chat of my current file. So this is the MCP communication which I was talking about. You can reject it or you can deny it based on what access it is having. So eventually it will list my pod, it will debug the error. Yeah, see, it tries to take a look at pods and what the error was eventually. So it identifies the issue and fixes it. And using the apply YAML tool, it applies the new YAML file and the pod starts working. It goes in the running state. All right. Yeah, so the key takeaways from this is we have a lot of applications, we have a lot of agentic AI workflows. Using the MCP tool, using the MCP server client, we can bridge the gap between your LLM, and we can have a lot more context to your LLM so that it can give you the prompt. It can return you the result based on your prompt in a very particular sequential manner. Then using the MCP, we can also have a agentic AI driven workflow in a lot of places. Then we can accelerate our development rather than copy pasting from one GPT to another GPT. You can just have an MCP configured. You can prompt the MCP, it will perform the actions for you. Yeah. Thank you.